that already contains the plasticizer. Immediately, you will notice that the texture is completely different from traditional concrete. Inside, I apply used motor oil as a release agent. Yes, motor oil, a practical and common trick in makeshift construction projects. It prevents the concrete from sticking and makes demolding easier with a cleaner finish. In this experiment, I will use 3 different molds, each prepared with the same care, but with small variations that will directly influence the behavior of the mixture. Next, I add 50 milliliters of plasticizing additive. In a 30-liter bucket, I add 2 liters of clean water and then add the powdered soap that we set aside at the beginning. Now comes the adapted mixer. Observe the high mechanical agitation. The intense movement causes the surfactant molecules in the soap to reduce the surface tension of the water. Here we are reproducing this phenomenon, but adapted for a home laboratory. Start adding the 7 kilos of cement little by little to the water that already contains the plasticizer. As you pour the material, notice how the mixture begins to gain consistency and body, creating the structural base of our experiment. Use a mortar mixer because it ensures a much more efficient mix. With this equipment, you avoid the formation of lumps, improve the hydration of the particles, and achieve a truly homogeneous paste with a uniform texture and ready to receive the next components of the experiment. When the mixture achieves a truly uniform texture, it's time to add the chopped fiberglass. This material acts as an extremely efficient structural reinforcement, incorporating the foam. Here I have approximately 30 liters of dense foam, specially created to give lightness and controlled volume to the mixture. And pay close attention to this detail, because it makes all the difference in the final result. Mix quickly. We're capturing the bubbles within the cement paste to create a cellular microconcrete. After that, add 1 kilos of plaster and mix again quickly. The plaster not only accelerates curing, but also increases the initial rigidity of the mixture, creating a firmer structure in the first few minutes. With the mixture fully prepared, begin pouring the material into the wooden mold. Immediately, you will notice that the texture is completely different from traditional concrete. The mixture is more aerated, visibly lighter, but still maintains a surprisingly firm and stable consistency. What we have here is, in fact, a structural foamed concrete made in an artisanal way, using simple yet extremely efficient principles. Remember, the ideal time for complete curing is 28 days to achieve maximum performance. But for this experiment, I will conduct the first tests after 48 hours, analyzing initial resistance, density, and surface behavior. These initial assessments already reveal a lot about the potential of this technique. Let's recap the function of each component. Cement acts as a structural matrix and base of resistance gypsum, accelerates curing, reduces density, and improves initial stiffness. Fiberglass provides structural reinforcement, crack control, and greater stability plasticizer. This technique already has industrial versions, but here we show how to adapt it with accessible materials, intelligent manual engineering, and a carefully controlled process to guarantee consistent results. After 48 hours of curing, the first of 3 tests in this experiment begins. The focus here is to analyze a hollow structural brick produced with a mixture of cement and powdered soap. A hollow brick made with regular concrete typically weighs between 8 and 9 kilograms. With this alternative formula, the final weight is surprisingly reduced significantly and completely unexpectedly. The weight dropped impressively. On the scale in real time, the brick shows a reduction of approximately 60%, a result that is completely out of the ordinary and already indicates the potential of this technique. I'm going to position the mold on the surface and observe, it floats. Now I'm going to test one of the most striking characteristics of this cellular concrete, something that simply doesn't exist in regular concrete. Using a handsaw, I'm going to cut the brick in half. Notice how easily the cut happens without damaging the teeth of the tool, indicating that the material is still damp inside, but has a firm structure on the outside. This behavior confirms the potential of this type of concrete for applications where lightness, workability, and insulation are crucial characteristics. After analyzing the 3 models presented in this experiment, it becomes clear that foamed concrete opens up possibilities for solutions that go far beyond the conventional.